In this last section of Chapter 9, we're going to be talking about significance tests for a population mean. So just like before, we're going to break this down into four videos. We're going to talk about the new pieces of the significance test, talking about those conditions and actually calculating the test statistic and the p-value. Then there will be a video on performance significance test, putting it all together. Then we'll look at a two-sided test, and then we're going to be talking about the power of a test. So for significance tests for means, our conditions are the random condition and 10% condition, the same as from proportions. But instead of having that large count condition, we have that normal/large sample. That's where if we know that the population distribution is normal or the sample size is greater than or equal to 30, then we know the sampling distribution is normal. However, if the population distribution is unknown and the shape is less than 30, then we need to use a graph of the sample data to assess the normality of the population. We do not use T procedures if the graph shows skewness, strong skewness, or outliers. On the AP exam, it's not enough just to make a graph of the data on your calculator. You must provide a sketch. So just a quick little dot plot to help show, or even a box plot, to help show that you graph the data and that it's approximately normal. So carrying out a test, here are the lifetimes of those 15 deluxe AAA batteries from the company's simple random sample. And so we want to check the conditions. So it's a simple random sample of 15 deluxe AAA batteries, and it's safe to assume that 15 is less than 10% of all the AAA batteries the company makes. And then here is a dot plot of that distribution. The dot plot does not show strong skewness. There really is not a peak, a single peak for us to use, and there's not any outliers. If you are going to determine if something is an outlier, if there is a possibility, make sure you use that 1.5 times IQR type of thing in order to determine if it is an outlier. So we have the standardized test statistic is equal to the statistic minus the parameter divided by the standard deviation of the statistic. Now remember, in a hypothesis test, we're assuming that the null hypothesis is true, so we're using the claim value average to be the parameter value. Now, in an ideal world, we would be using sigma. We would know the standard deviation of the population. That'd be great. But then if we know the population standard deviation, then that means we have all the data and we don't really need to do any of this. But because it's pretty much never known, we use the sample standard deviation. So the resulting standardized test statistic has the standard error of x bar in the denominator. Alright, so remember when we're doing this, we're going to be using the t distribution. So we need to look at our degrees of freedom. Remember, degrees of freedom is one less than the sample size. And as our sample size increases, our graph becomes more and more like the z curve. So if our sample size is increasing, that means degrees of freedom are increasing. So you can see that with 2 degrees of freedom or 9 degrees of freedom, going from the dotted graph to, or the dashed graph to the blue dotted graph, it then comes closer and closer, looking like the standard normal curve, which is the z curve that we know of. Alright, so when we perform these, our degrees of freedom are n minus 1, that t distribution is similar to the normal distribution, but it has a little bit more area out into the tails because it's not quite the standard curve. So you see there's some gap here. That means if we were looking at this value, the standard curve would have a smaller area than the t distribution that goes with it. So we have a little bit higher probabilities with t distributions than with our z scores. Alright, so putting it all together here, the idea for the batteries was that their average lifetime was 30 hours, and hopefully the deluxe batteries have a larger lifetime, so greater than 30. So from the sample data, the average X bar was 33.93. So when we subtract 30 divided by, and then from the data we had to find the standard deviation of those 15 values divided by the square root of 15. So we get a t-value, a test statistic of 1.55, and the degrees of freedom is 14. So you go down your degrees of freedom column to 14, and so our p-value going up, we have between 0.05 and 0.10. On your calculator, of course, it's going to give you the exact p-value. If the degrees of freedom you need isn't provided in the table, remember you use the next smaller value that's available. So suppose you want to perform a test where our null hypothesis is mu is 5 versus the alternative mu is not equal to 5 at the significance level 0.01. A random sample of size 37 from the population yields X bar is 4.81 and the standard error is 0.365. Assume that the conditions for carrying out the test are met. So explain why the sample results give some evidence for the alternative and calculate the test statistic. Well, the X bar value, the sample average, is 4.81, which is less than 5. So we're at least getting something different. No, this does say not equal to. So now for our test statistic. So t equals 4.81 minus 5 divided by 0.365 divided by the square root of 37. So we get a negative 3.17, and our degrees of freedom are 36. Now this is not equal to, so this is a two-sided test, so we're looking at the area greater than and less than. So we're going down our chart. 36 is not on our degrees of freedom, so 30 is the next one. And then we go across, matching up for our significance level of alpha is 0.01. So that gives us between two values. Here's 3.17 is what we're looking for, and that is in between these two. So we have a p-value between 0.001 and 0.0025. Again, you can use your calculator if you want. But remember, because this is a double-sided or two-sided test and not equals to, when we said it's between 0.001 and 0.0025, we actually need to multiply those by 2, so we get that it's between 0.002 and 0.005. So our p-value is between that, so then you'd compare to alpha. Using your calculator, you would go to Menu, Statistics, and you would go to your stat tests, and this is a t-test. Remember that first group, z-test and t-test on the calculator, is meant for a one sample with means.